It should be there now. It,
No, sir, you aren't sharing anything.
it should be there.
Okay, now I can, yeah.
Okay. So done. Done. Today I'm using a new app. So we'll be using it for the first time. And this is explain everything. Okay. So we are beginning with the new topic, that's waves. What? Waves. Right? Waves. And in the section of waves, we are going to be talking about general wave properties, general wave properties, general wave properties. Then we have the topic of light. Then we have electromagnetic spectrum, electromagnetic spectrum, and then we have sound. So these are the four chapters that we will be covering under this chapter, under this section of waves. Okay. All right. So when we talk about waves, the first topic is general wave properties. Let me know what is the first thing that comes to your mind when you see the word wave. Yes, Zen. What is the first thing that comes to your mind when you hear the word wave?
Sir, sound,
Sound. Okay. What else?
the sea,
C. Excellent. What else? Right.
radi-
So good. Hmm?
radiation,
Radiation. Good. So these are all the examples that should come to your mind. Yes, rightly identified when you hear the word wave. So basically, when we talk about wave, wave is what? Wave is basically a mechanism in which energy is transferred. Wave is a mechanism in which energy is transferred from one point to another without the transfer of medium. Right? What is wave? Wave is a mechanism in which energy is transferred from one point to another without the transfer of medium. Right? You must have in grade 9 or grade 10 maybe, you must have heard the methods of transfer of thermal energy. What were they? They were conduction, they were convection, radiation. These three were the methods of transfer of thermal energy. But now we are going to be talking about waves. Waves is the transfer of mechanical energy from one point to another without the transfer of medium. So if somebody asks you what is meant, what is meant, what is meant by wave motion, what is meant by wave motion, or what is meant by wave, you will simply say it's the transfer of energy from one point to another. It is the transfer of energy, or maybe you can call it disturbance. It's the transfer of energy, or maybe you can call it disturbance from one point to another. From one point to another. without the transfer of medium. Without, I hope my writing is readable. I mean, it's
Yes, sir, it is.
not very light. Without the transfer of medium, right? Okay, is this fine? Any problem? Any confusion?
Sir, can you make the lighter color darker tone?
Okay. It's written without the transfer of medium. Without the transfer of medium, right?
Okay, sir.
Okay. You must have seen. ये बनवाया कैसे आते हो आप चेक करो फिर दे दो ये है उसके अंदर चेक करो नहीं अच्छा है तो हम लड़कियों में से तो हमने अरे बनाओ ना इसकी इसको बीच में लगाओ अभी नहीं अभी जरा क्लास के बाद ओके ऑलराइट सो okay, just look carefully, watch for a minute, and let me know what do you observe.
Sir, as the gear rotates, the waves are going up and down.
Okay, let's imagine that you do not see the wheel. क्लास शुरू तो हमको अभी वो ठीक है हेलो नहीं मैंने कहा उस्ताद जी पूरी कर दे आप उस्ताद जी पूरी कर दे मसला नहीं आप लोग जो भी डिसाइड कर लें मसला नहीं ओके अल्लाह हाफिज all right so you can see that there's this green particle which is moving up and down right
Yes, sir.
this green particle it's moving vertically up and then it's vertically moving down but you see that there's a wave that's moving to the right side is it this green particle it's moving up and down, but you see a wave proceeding to the right. This green particle moving up and down, but you see a wave proceeding to the right. Is it? This
Yes.
was a wave on a rope. This was a wave on a rope. Similarly, you may find one more example over here. All right. You see, there's this drop, 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 drop. This is a disturbance created just at one point, isn't it? A disturbance is created just at this one point. And you see, this disturbance proceeds to the right. This disturbance proceeds this way. Hmm? This disturbance moves this way. Is it? So, again, what you found was this water particle oscillating up and down, hmm, and transferring its energy to the neighboring. So, you see, that energy is transferred without the particles moving from one point to another. Without the particle moving from one point to another. The particle is just vibrating about its fixed position. Is it?
Yes, sir.
Is it like that?
Yes, sir.
Hello? Then you must have seen, do you go to gym? Do you go to gym?
Yes, sir.
Have you done that rope exercise?
No, sir. Doesn't do anything.
Where? Hmm?
So it's not useful.
It's useful?
No, sir, it isn't.
It isn't. All right, you have not done. So if it is useful or not, but we can. It's useful to us today. It helps us to understand one concept of waves. You see, you hold one of the part end of the ropes, one of the end of the ropes. You oscillate that one end up and down. You oscillate that one end up and down, right? And when you oscillate it up and down, you see a wave proceeding to the right. Is it? When you
Yes.
oscillate one end of the rope up and down, you see a wave proceeding to the right. So, again, what has happened? Energy has transferred from one point to another without the transfer of medium. What is medium? Medium is the particles. Medium is the particles. Zishan, medium is the particles, right? Particles of flow, particles of water. Hmm? Do you know anything about Mexican wave?
No, sir.
Mexican wave. Okay, what is your favorite sport?
Basketball.
Basketball. Have you ever seen a basketball national or international match in which there's a huge audience?
Yes, sir. Oh,
All right.
yes. When the audience goes up and down.
Exactly. What happens? The audience, when they support their team, they do hooting. What happens? The participants just move up and down on their own seats. Hmm? They move up and down on their own seats, right? But you see a wave being formed. You see a wave being formed. Now, what was the medium at this point? The audience. The audience. Okay? The audience was the medium. You see that the spectators, the audience, they are seated, they are there at their own place. They are vibrating up and down at their own place. But there's a wave that's forming, moving to the left and right. Is it?
Yes, sir.
Right? So, wave is the transfer of energy from one point to another without the transfer of medium. Without the transfer of medium. Now, so so you can see, let's say, if I have to categorize them in terms of wave direction and direction of vibration, I have two categories. Either a wave is A wave is going to be a wave is going to be transverse. A wave is going to be transverse. Or a wave is going to be longitudinal. A wave is going to be longitudinal. This is one, right? And then if I talk about the examples of transverse waves, in transverse wave you would find water waves. Water waves are transverse waves. Water waves are transverse waves. You would find waves on a rope. Waves on a rope. You find waves in form of sound. Wave on two, and then that is called as
Sir, your voice is lagging a lot.
okay. I hope it's not now.
No, sir, it is not.
Is it better?
Yes.
Okay. Just 1 minute. Just 1 minute. I'm connected to the other Wi-Fi. I hope it's better now.
Yes, sir, it is.
Okay. So I was discussing with you a category, and that's called electromagnetic waves. Electromagnetic waves. All electromagnetic waves are transverse waves, but electromagnetic waves are itself a category. And parallel to this category is another category which we call mechanical waves. What? Mechanical waves. Acha ji. Electromagnetic waves are waves which do not need a medium, a medium, right? Which do not need a medium. That means they can travel through vacuum. They can travel through vacuum, right? And then in mechanical waves, these are waves who needs a medium to travel, to travel, right? That means they cannot travel through vacuum. They cannot travel through vacuum. Okay, got it? Any problem? Any confusion?
No, sir.
All right, going further. Let's discuss about transverse and longitudinal waves. Remember that every wave, this is a point to be noted, every wave has two directions. Two directions. What does that mean? It means it has a direction in which particles vibrate. We call that direction of vibration. Direction of vibration of particles. Direction of vibration of particles. And then we have a direction which we call direction of wave travel. Direction, direction of wave travel. Okay, direction of wave travel. What do I mean by that? You just saw a while ago that when the rope was oscillated up and down, there was this green particle. I made green particle the benchmark, but rather there was every particle which was oscillating up and down, which was oscillating up and down, right? Which was oscillating up and down. Hmm? And you saw
Yes.
the wave moving to the right. You saw the wave moving to the right. Is it?
Yes, sir.
So that means there's one direction. This is the direction of vibration. This is the direction of vibration. Direction of vibration. And this is in which the wave is moving. This is the direction of wave travel. Direction of wave travel. The direction in which the wave is moving. The direction in which the wave is. The direction in which the wave is moving, right? We can call this wave propagation also. The direction of wave travel or the direction of wave propagation. We also call this the direction of wave motion. Is this understood?
Yes,
Any
sir.
problem, any confusion so far?
No, sir.
All right. So I'll just quickly. All right. Here I would like to mention one thing. Let's say if there's a wave like this, which you have just seen, in which the direction of vibration is this, direction of wave propagation is this to the left, right? And then the direction of vibration of particles is this. What do you see? What is the relationship between these two directions? What is the relationship between these two directions? Yes, can you tell me?
Sorry, sir.
What what is the relationship between this direction of propagation and direction of vibration, right? One is vibration and the other is propagation. What is the relationship between these two directions? What do you find? What is the relationship? Yes,
Sir.
Zen? It's 90 degrees, isn't it?
Yes.
So that means when the direction of vibration and direction of wave propagation is just like you see on the screen, that is, they are at 90 degrees to one another. What does that mean? That means that means this is a transverse wave. बेटा जा रही हैं आप, टाइम पे आइएगा वापस वरना बैठ जाइए. नहीं, आप टाइम पे नहीं आती. आप टाइम पे नहीं आती. All right, so basically this is called a transverse wave. This is a transverse wave. Okay, this is a transverse wave. Do you get this? When the direction of vibration of particles and the direction of wave propagation is perpendicular, the wave formed is called a transverse wave. I'll just write it here. In transverse wave, direction of vibration of particles, direction of vibration, direction of vibration of particles, and direction of, I hope you are noting everything down,
Yes, I am.
of wave propagation, wave propagation is perpendicular. Got it? बात समझ आ गई बेटे?
Yes, sir.
All right. Now that was an example of flow. Let's see. Let's say you have a spring. I'll better take a picture from Google. All right. So you see, this is a spring, and when you vibrate this spring forward and backward, like this, when you oscillate this spring forward and backward, what would you see? You would see compressions forming. What? Compressions forming. You would also see rarefactions forming. You would see compressions forming. Is it? So Zen, tell me, what is the direction of vibration? This horizontal, right? You're going it moving it forward and backward, or you are moving it left, right. Left, right, is it? But you see these compressions also moving left, right, isn't it? The compression will also move left, right. So this was the direction of vibration. And the movement of compression and reflection is what? Is a wave. What is that? That is a wave. So you see that the direction of wave propagation and the direction of wave, they are parallel. They are parallel. They are parallel. Is it?
Yes, sir.
So when the direction of wave propagation and the direction of wave particles that are vibrating, it's parallel, we say the wave that results is known to be longitudinal wave. What? Longitudinal wave, right? Longitudinal wave. So in longitudinal wave, what happens? Direction of vibration, direction of vibration of particles is parallel to the direction of wave propagation. All right, then.
No, sir, I'm right.
Okay.
Yes, sir, I wrote it.
Okay. Now the next thing that we are going to do is wave terms. What? Wave terms. To understand wave terms, I'll take you back to the feet Colorado, and I'll make this oscillate once again. I'll increase. All right. I'll remove the damping. I'll increase the frequency. And then I'll make it slow. And then, okay. So all right. So what do you see? You see that as the wave moves from left to right, this particle is at maximum distance. This particle is at maximum distance from mean position. Is it? This dotted line is called the mean position. This is this is the mean position, right? Mean or rest position. Mean or rest position. Okay? This is the mean or rest position. So you see, this is the maximum distance this particle has covered. Hmm? This is the maximum distance. In fact, if we do it more precisely, we would say that this is the y-axis, and then this is the x-axis, right? On y-axis, usually what we do, we use displacement. We use displacement, right? This is displacement. And on x-axis, we use distance. We use distance. So this is the maximum displacement that this particle has covered. We call this maximum distance as amplitude. Hmm? This is another maximum distance the particle has covered from mean position. We call this maximum distance, a maximum displacement, my bad, as the amplitude of the wave. As the amplitude of the wave, right? Then this particle itself, this only particle, see, I am circling this. This particle is called the crest. This particle is called the crest. What is crest? A point of maximum displacement, a point of maximum displacement from mean position. And this particle alone, just this particle, see, I'm encircling this. This is called the trough. This is called the trough. Trough is what? A point of maximum displacement below mean position. A point of maximum displacement below mean position. Now, Zen, look carefully. You see this wave started right here. This wave started right here. And as it proceeds to the right, what do you see? As it proceeds to the right, this wave continues to form like this, and you will see that when the wave reaches here, hmm, you see that same structure begins to repeat once again, isn't it? The
Yes.
same structure begins to repeat, whatever the structure was here, whatever the structure was here. Hmm? That same structure will begin to repeat here, isn't it?
Yes, sir.
So this is basically this length, which I'm highlighting again. This length is known to be the wavelength. This length is known to be the wavelength, right? This length is known to be the wavelength, and we represent it with the letter lambda. We represent it with the letter lambda. All right.
Yes, sir.
Okay. Wavelength represented with letter lambda. Now, So how many terms we have discussed here? How many terms have we discussed here?
Sir, so
Amplitude, crest, trough, wavelength. Hmm? These are the
yes.
terms that we have discussed. ओके अहमद भाई इसको फ्रिज में रख दें खराब हो जाएगा पहले मेरे जहन में नहीं था ऑलराइट आपको क्या बाद में ले हाँ okay I'm taking the example of that same wave but this time I'll be altering the axis a little. Okay, so see this time this is the same y-axis, that's displacement, but this x-axis this time I'm making it to be the time axis. Previously it was distance, right? Now it's time axis, time in seconds. So this point is the same crest, this point is the same trough, this displacement is the same displacement which we called amplitude, but okay, this distance, this gap, what is this called? The one I'm highlighting yellow, what is this gap known to be? What is this gap known to be?
Sir, which one?
Hmm? The one I have highlighted orange sort of
Sir, the wave,
wavelength. But is this x-axis representing length?
the distance.
Is this x-axis representing the distance?
No,
What is it representing?
the time.
Time. So that means this is the time of the wave. This is the time of the wave, which we call the time period, right?
P-
The same gap, which was wavelength, is now time period because previously that was distance. That was distance. Now this is time, not distance, isn't it?
Yes.
So the same gap is known to be time period. Got it? Any problem? Any confusion?
No, sir.
All right. Then I'll just import that. These are the terms that I have. These are the terms that I have just highlighted. Okay, so that's done. Then All right. Now, one more thing. This is a usual wave, which we saw that there was one wave forming. Now, what I do, I increase the frequency. So, what happens now?
It's going faster.
It's going faster, or there are more number of waves formed.
It's more number of waves.
More number of waves formed, right? So, this is wave with more frequency. Hmm? Right? So, there are how many waves formed in that same time? Let's say if I begin from here, if I begin from here, this is the first wave. hmm And then this is the second wave. And then finally, this is half a wave, right? So wavelength, wavelength, and half wavelength. So 2.5 waves. 2.5 waves are formed. 2.5 waves. This is wave 1. This is wave, or I would say frequency 1, more appropriate. Frequency 1. Okay? All right. And then let's say I reduce the frequency. Okay. So that same time is the same. Now this is the new frequency. I'll call this frequency 2. Frequency 2. You see, there's one wave forming. One wave forming. One wave forming. So lower frequency. What? Lower frequency. Got it? It's lower frequency. Any problem? Any confusion?
No, sir.
All right. So I'll just import these two pictures as well. All right. Got it. So these are all the terms. I would want you to make these waves.
So after you're done, can you send the notes on the group?
I will send them, or you can take a screenshot. No, no.
No, sir, the whole note.
Okay, I'll send the whole note as well. No problem. But since I'm doing this on this new app, so I'll be looking how I can extract them. Okay.
Okay, sir. Thank you.
When you are done making them, let me know. Okay.
Uh,
Done.
yes.
Okay. This is where I have noted them all together. I'll send you a video of this as well, right? Okay. Here is all the wave terms. Yeah. These are the wave terms that I would want you to note them down. अल्हम्दुलिल्लाह भाई बात सुने भाई मसला ये है यार पता है ये कहां गिरी हुई कहां से लाए मेरे बच्चे जो है ना वो एक एक पीस में डबल मजे ले रहे हैं मैथ्स और फिजिक्स साथ साथ चल रही है कैसे वो रिकॉर्डिंग हो रही है आपकी आवाज माशाल्लाह से हमारे साथ कॉम्बिनेशन नहीं बना है मेरी आवाज तो मुर्दों को उठा देती जबरदस्त ना तो वो बच्चे अभी तो ब्लॉक कर दे अभी तो रिकॉर्ड भी हो गई साथ गई है वो लोग कहते हैं जो चीज का फायदा उठा लो अंदर चला जाता उससे बात खत्म हो गई जैन यू डन
No solve.
all right let me know when done I'll just show all this यार ये क्या लाएगी उसमें ये नहीं बताऊंगा.
Yes, sir, I'm done.
Done. मान जा.
Yes.
ये pendulum के experiments के लिए. Okay, done. So we'll keep it till here. I'll send you this file, and we'll continue from this point in the next class. Okay. Is our time done? Let me check. Uh, it's 58 minutes. 2 minutes are remaining. Okay. So Sayyid, we'll keep it till here. All right.
Yes, sir.
It's 58 minutes. Okay. So Allah Hafiz. Assalamu alaikum.
Allah Hafiz. Walaikum salam.